Say I've got a roller coaster going on a circle like this, starting to go up the loop. Goes up here, makes it to the top, barely makes it around the loop. Okay, so it's going around, it's going to continue on moving in the circle, everything's going to be safe, no one's going to get hurt, but it barely makes it around the loop. How would we analyze this problem? What forces act on this roller coaster car at the top of the loop? What's one of them, Rachel? Gravity. Gravity acts downward. What else acts on this roller coaster car at the top of the loop? Patrick?
Patrick, go ahead.
Sorry. Parker, Patrick, they both start with P. Parker. The normal force. Parker, which way does the normal force act? And now we don't know how big the normal force, well actually if we're looking for minimum speed, we do know how big the normal force is. Normally we say that the net force is equal to the sum of the forces here. But if we're looking for the minimum speed, in other words the speed at which it just barely makes it around, what's the value of the normal force there? Yeah, it's 0. Now, we usually set it up like this, and then if we're looking for minimum speed, then we cross off the normal force. If we're not looking for minimum speed, then let's not cross off the normal force. It's going faster than it needs to make it around, then leave that normal force on there. Now, the net force is also equal to what? The net force is? Good. It's the centripetal force, mv squared of r. Remember we said the centripetal force toward the center of the circle, always caused by something. In the case of an object going around a vertical circle, it's always caused by two things, actually, gravity and the normal force. Well, in this case, one, because normal force canceled out. Gravity is m times g. Masses cancel, which is good news. We don't have to worry about who's sitting beside us. We don't have to have an optimum weight. Okay, this person's not going to be too light or too heavy sitting next to us. Okay, if we're going to make it around, we're going to make it around. If we're not, then we're not, regardless of who's beside us. Let's sub some numbers in. Well, at this point, we sub some numbers in here. But as you do that, remember to make this negative, because centripetal force is toward the center of the circle. And remember to make this negative as well, because gravity is downward toward the center of the circle. Now, what if I was looking to analyze the bottom of the circle? So let's say we solve for the minimum speed here. And it worked out to be, let's say, I don't know, 10 meters per second. Exactly 10 meters per second. Now we want to find out the force of the track, which corresponds to the normal force, at the bottom of the circle, at that speed. So you're going just barely fast enough at the top, you continue going around at the bottom, 10 meters per second, what's the normal force acting at the bottom of the circle? Well, then we got to say, well, the force of gravity acts down, and the normal force acts up toward the center. Notice the normal force is bigger here because you're not going to stay in a circle if the normal force isn't bigger. Here we'd say F net is equal to Fg plus Fn. mv squared over r is equal to mg plus Fn. And if we were looking for the normal force, we'd solve for Fn. Okay, what about gravity here? Positive or negative? At the bottom of the circle, positive or negative? Negative, because it's acting down. What about the normal force? Positive, because it's acting up. And what about the centripetal force? Once we start subbing numbers in, look, centripetal force is toward the center. Where are you? Bottom. Which way does centripetal force act? Up, toward the center of the circle. So that's going to be a positive value as well. All right? Question? No? All right. You good with that? Okay, here's fake quiz number 13. Fake quiz number 13. I'm just going to put it on the board right now. We've got a car at the bottom of a circle, and here we've got a car at the top of a circle. The radius of the circle in both cases is 15 meters. The speed of the car at the bottom and at the top is, we're going to make it 20 meters per second. We want to find the normal force at the bottom and at the top of this circle. Now, what else could I have asked? Like how else could I have asked the same thing? Instead of saying find the normal force at the bottom and the top, I could have said find the tension. I could have said find the force of the track at the bottom and the top. I could have said find the, not the actual weight, the apparent weight. Any of those things mean the same thing. So in our practice quiz, I'm asking you for the normal force, but I could absolutely tomorrow on your real quiz ask you for the tension or the force of the track or the apparent weight or whatever. All right, so set both of these up and then solve for the normal force in both cases. Hey, one quick thing before I let you set you free here. Where do you think the normal force is going to be bigger, bottom or top? Where is it going to be a higher value, bottom or top? At the top, they're both pulling in the same direction, right? At the bottom, they're opposing each other, gravity and the normal force. If you're in a tug of war, when is the tension in the rope highest? When everybody's pulling in the same direction or when you're opposing each other? When you're opposing each other, right? So we would expect the biggest normal force to be at the bottom of the circle. Okay? So solve that and make sure you get a normal force at the bottom that's bigger than it is at the top. Otherwise, you've made a mistake. Sorry. One should be at the top. One should be at the top and one should be at the bottom. And yeah, there should be a mass here as well. We'll just go mass of the person. We want to find the normal force acting on the person inside. And the mass of the person is going to be 70 kilograms at the top and at the bottom. For the first one, where the object is at the top of the circle, our two forces that are acting are gravity and the normal force. How big is the normal force compared to gravity? We're not sure. Let's just draw it the same, roughly the same length. At the bottom of the circle, the two forces that are acting are once again gravity, same value as it is at the top, and the normal force, which we know has to be bigger and acting toward the center of the circle, acting upwards when we're at the bottom of the circle. Now, if I ask you to find the actual weight here, the actual weight, I'm looking for the force of gravity, m times g. You don't need to go through this process of F net is equal to the sum of the forces, because force of gravity is just m times g. But if I ask you for anything else, you need to go through that process of saying F net is equal to the sum of the forces, Fg plus Fn. Top and bottom of the circle, F net is equal to Fg plus Fn. Now, again, top and bottom of the circle, we'll say mv squared over r equals mg plus Fn. Exactly the same so far. If we were looking for, at the top of the circle, the minimum speed, what would we do to this? We just talked about this a minute ago, right? What would we do? We get rid of Fn. So we're not looking for minimum speed. We're solving for Fn, in fact, so we got to leave it there. Start subbing in some numbers here now. M is 70 times 20 squared over 15 equals 70 times 9.81 plus Fn. Now we've got to worry about positive and negative here. Gravity, negative or positive? Negative because it's acting down toward the ground. Centripetal force, negative or positive? You're at the top of the circle right now. So it's negative because the center of the circle is downward from you, below you. Make it negative value. Let's calculate these values. Say 70 times 20 squared divided by 15 gives me a value of 1866.66. Negative equals 70 times 9.81 gives me a value of 686.7. Now we're going to take the 686 over to the other side by adding, because it's a negative value. So we get negative 1866.6667 plus 686.7 gives me a value of 1179. Fn is equal to negative 1179, which rounded to two digits actually gives me negative 1.2 times 10 to the 3 newtons. It's a negative value. Should it be? Sure it is. We established right at the beginning that the normal force is acting down. We should get a negative value for that. All right, what about the bottom one here? We know what mv squared over r is. We already figured that out. It's 1866.667. We know what gravity is. Already figured that out. It's 686.7 What about positives and negatives? Gravity is negative because it's down. Centripetal force is positive because it's up. So the only difference between this question and the last question is that centripetal force is positive versus negative. But you can see how when I set it positive, I'm going to get a different answer here. Positive 1866.667 plus 686. That should be 686.7, right? We end up getting 2553, or we'll say Fn is 2.5 times 10 to the 3. Positive should be, because we know the normal force is up. What do we predict? Did I make a mistake? What is it? Is it 2.6? Yes, you're right. 2553. Look at the third digit. It's 5 or bigger, so it rounds up to 2.6 times 10 to the 3. Thank you. Good, there you passed the test. Let's say that I did that on purpose and that I wanted to test you to see if you'd catch that. Good job. All right, 2.6 times 10 to the 3. It is positive because it's upward. We know that. And we predicted that the normal force at the bottom of the circle would be higher, just like force on tug of war is higher when you're opposing. And sure enough, it is higher.